Okay, so in the first problem, you were going to be converting moles of iron of Fe2O3, iron oxide, to moles of oxygen to eventually mass of oxygen. Okay, so in this problem, that's where you're starting and that's where you're going. And so we need our mole ratio first, but we're going to take our given, which is 2.36 moles of Fe2O3 and put it over 1. And when we go mole to mole, we need to use the mole ratio. And the mole ratio here, we are comparing Fe2O3 to O2. So the ratio is 3 to 2 or 2 to 3. I am going to put the 2 moles of Fe2O3 on the bottom and the 3 moles of O2 on the top. Yes, sir.
Does it matter where you put it?
Actually, yes. You want to make sure that the question is, does it matter where you put like the 2 or the 3? And in this case, it does matter in large part because you want to make sure that the unit of moles of Fe2O3 cancels out. And so that means a 2 has to go on the bottom. And so with that question, we're going to lead into calculating the mass. And when you calculate the mass, in problems like this, you're going to calculate the molar mass. And the molar mass for O2 is 2 oxygens times the mass of oxygen, which is 16.00 grams, which is 32.00 grams of O2 in 1 mole. Now this time the mole has to go on the bottom again because it's 1 mole of O2 on the bottom, and we're going to have 32 grams of O2 on the top. So using our calculator, we're going to multiply straight across. So 2.36 times 3 times 32. That answer divided by 2 gives us a value somewhere around 113.28. We're going to check significant figures, real quick ones here. I'm going to draw this arrow and count 1, 2, 3. That's 3 sig figs. These both have infinite sig figs. This value here is 1, 2, 3, 4 sig figs. So I'm going to need 3 sig figs. So 1, 2, 3. This 2 does not round the 3 up. So my final answer here is going to be 113 grams of O2. And then in the next problem, we are converting grams. So we're going to go from mass of O2 to moles of O2 to moles of Fe to mass of Fe. So in our first part of this problem, I'm going to take the 100 grams of O2 and put it over 1. And I'm going to go mass to moles. And when I go mass to moles, I need to use the molar mass. And I'm not going to recalculate the molar mass because I did it just above up here. So like here's my molar mass for O2. So I'm going to bring that down and use that here. So I see that it's 32 grams of O2 equal to 1 mole of O2. And now I'm going to go mole to mole, so I'll do the mole ratio. And this time, my mole ratio, I'm comparing oxygen to iron. So this is a 4 to 3 or a 3 to 4 ratio. And this time, the 3 is going to go on the bottom. So I'm going to put my 3 moles of O2 on the bottom to cancel out moles of oxygen. And I'm going to put my 4 moles of iron on top. Mass to mole, mole to mole, mole to mass. When we're using mass in these problems, we need to use the molar mass, which is the mass on the periodic table. So I have 1 iron, right, times the mass of iron, which according to the periodic table is 55.88 or 85. So it's 55.85 grams. Of iron because there's really only 1 of them. And so then that's going to give me per mole per 1 mole specifically. So I'm going to have my 1 mole of iron on the bottom and 55.85 grams of iron on the top. Multiply across and then divide. So 100 times 4 times 55.85. That answer divided by 32 divided by 3 gives me an answer of 232.70833 something. We're going to check Sig Figs real quick once. So I draw my arrow here and count 1, 2, 3 Sig Figs. This arrow here gives me 1, 2, 3, 4 Sig Figs. These are both infinite Sig Figs. This arrow here tells me it's 1, 2, 3, 4 Sig Figs. So my final answer needs to have 3 Sig Figs, 1, 2, 3. This 7 will round that 2 up. So my final answer here is going to be 233 grams of iron. And then lastly, we are asked to convert moles of Fe2O3 to moles of oxygen. So we are starting with moles of Fe2O3, and we're going to go to moles of O2. So I'm going to take my given, which in this case is 4.50 moles of Fe2O3, put it over 1. And when we go mole to mole, we need to use the mole ratio. So this time we're comparing Fe2O3 to O2. So here we're comparing Fe2O3 to O2. So it's a 2 to 3 ratio, right? So I'm going to set this up so my Fe2O3 cancels out. So I'm going to put 2 moles of Fe2O3 on the bottom and 3 moles of O2 on the top. I'm going to multiply straight across and divide. So 4.5 times 3 divided by 2 gives me, the calculator tells me it's 6.75. I'm going to check my Sig Figs real quick once. This is 1, 2, 3 Sig Figs. These are both infinite. So this answer has to have 1, 2, 3 Sig Figs. So my final answer here is going to be 6.75 moles of O2. Now, there's one thing that I really want to impress upon you. I'm trying to make this as clear as I possibly can. If you don't have a unit and a label, a unit and a label, and a unit and a label, even if your answer is correct, you're going to lose some points. You've got to show the work. You've got to show the unit and the label. That also goes during your problems, right? So like if you did this one here and you were like 4.50 times 3 over 2 gives me 6.75, let's say, moles of O2, because you don't have moles of Fe2O3, moles of O2, and moles of Fe2O3, you're still going to lose points there. So really, really, really be in the practice of showing your work, showing the units, showing the labels. Any questions on the first page? Okie dokie. Going to the next page. Oh, we did the math for you. Look at us. We're so nice. So first thing you have to do is identify the theoretical yield and explain. So the theoretical yield is this value here. It's the smaller answer to the math problem. So in this one, it is 1,110 grams of zirconium chloride. And the reasoning is because this is the maximum amount of product that can form when the limiting reactant is used up. So I'm looking for you to say something to this effect. This is the maximum amount of product that can be formed when the limiting reactant is completely used up or gone. Just like yesterday we talked about the ham. The ham was the limiting reactant in my sandwiches. Once all of the ham was gone, I couldn't make any more sandwiches. So that leads me to what's my limiting reactant? Well, my limiting reactant is going to be this one right here. It's going to be the 870 with a decimal point grams of ZrSiO4. And the reason for that is because this reactant gets used up completely first. So I'm looking for you to say something like that. And then by, I guess, process of elimination, the 950 grams of chlorine is going to be my excess reactant. And that'll be because there will be some chlorine left over when the limiting reactant is used up. So that's that's kind of what I'm looking for you to tell me tomorrow. Something to that effect, something in that vein. Lastly, I'm asking you to calculate the percent yield. Oh, look at this. It's a very similar problem. We've seen this problem a bunch of times already. Okay, so here we go. We have our theoretical yield right here, which is important because we're going to use it in our calculation. So this question says determine the theoretical yield. Done. Check. Got it. Then calculate the actual yield. So we're calculating the actual yield in this problem to obtain a 75% yield. So we have to remember that our formula for percent yield, right, is percent yield is equal to actual yield over theoretical yield times 100. So in this problem, we know the percent yield, right, is supposed to be 75%. And we are going to calculate the actual yield. And we know the theoretical yield is 1,110 grams of ZrCl4. So the first thing I'm going to do is divide both sides by 100. And when I do that, I get 0.7500 is equal to actual over my 1,110 grams of ZrCl4. Now, I'm going to multiply both sides by 1,110. And so I'm going to calculate that with 1,110 times 0.7500 gives me a value to be something like 830, 3 grams of ZrCl4 is the actual yield. Questions about that one? Because that one I think is a little bit more complicated of the two. So far, so good. All right. So then using the information above, calculate the percent yield. So this one is asking me to calculate the percent yield when I know the actual yield is 952 grams. So again, my formula is percent yield is equal to actual over theoretical times 100. So in this problem, we know the actual that's recovered is 952 grams of ZrCl4. And we also know that the theoretical yield, because that has not changed, is 1,110 grams of ZrCl4 times 100. So 952 divided by 1,110, that answer times 100 is going to give me a percent yield something around 85.77. Nope. Yep, 77%. Percent. And that's that. So hopefully that doesn't feel too bad for you. Hopefully you're really excited about your Quizzy Poo tomorrow. I will post the answer key in the video for this on Google Classroom shortly. But if you have any questions, please let me know. Otherwise, good luck.